Hello and welcome to day 11 of my Inventor IO 30 Days Lost in Space adventure. In this lesson, they go over installing the 4x4 numeric pad. So there's 4 rows of 4 push buttons that link to the board with this piece of ribbon cable here. These are what they call DuPont connectors. These are male, and this side has female, and they plug into the pins that are on this numeric board. So I figured I would play a little bit with PWM before I disassembled my board completely. And what I did was I utilized the multicolor LED, and being that this isn't my first delve into C language proper, I know enough of it to make me dangerous, so I wrote a for loop, which is kind of like the infinite loop that we have inside of the Arduino IDE. But what the for loop is it allows us to create a conditional loop inside of the void loop that lets us count up or count down with an incremental variable. So what I did was, I'll plug it in, I'll show you. So basically all I'm doing is I'm using the PWM signal with the for loop to count up from 0 to 255, and then once it reaches 255, count from 255 back down to 0 with red, green, blue, and then all 3 together, which will create white. I'm sure there's a different way to do it, but I just wrote a bunch of different for loops that just progressively went through red, green, blue, and then white. I'm sure there's some way to embed logic into it with arrays and whatnot to give me what I wanted. But this is my last delve into it before I rip everything apart and get this thing plugged in. Okay, so I've got my number pad all connected with the DuPont connectors. This was originally a solid ribbon cable, but makes it easier to rip off the pieces that you need and just connect what you've got. So I connected the pin headers to the DuPont cables, plugged them into the inputs on the board as per the diagram. I'm going to watch the video, punch in the code, and then I will meet back up with you in the computer view. Alright, after just spending the last 20 minutes recording my spiel for this video, I realized that I forgot to turn off the reverb effect on the preset that I'm using on my vocal processor that I run my microphone into before I send it to the computer for recording. But if you wanted to hear a rendition of 46 and 2 from Tool, that's the vocal patch that I'm using at the moment, just without the reverb. Anyway, sorry for the delay. It's actually been about 4 days since I did my initial video from the camera view. I kind of got caught up with working on one of my machines and International Carrot Day and things like that, so haven't had a chance to get back to this, so sorry about the lapse in time. But I watched the video, I put in the program, which isn't very long, but they do introduce a lot of new functions or new tricks or what have you. They go and they add this keypad.h library, which contains a bunch of functions all in itself to assist with creating the array that is required for the 4x4 keypad. They go through how to download and install it, so I'm not going to get into that. But they're using the #include key.h, #include keypad.h, And they even say you could tell that the function is, or the library is installed because keypad lights up in an orange. Create constant byte called rows, set that to 4. Constant byte called cols, and set that to 4. And what this does is it establishes the grid layout of the keypad. So there's 4 rows and 4 columns. On the keypad itself, there's 8 pins that come out of the keypad, and 4 of them are for the rows and 4 of them are for the columns. And then the voodoo magic of the PCB in relation to where the buttons are pressed will divide the signals accordingly to know exactly which button you are pushing on the board based on those 8 pins. Underneath that, we create a character variable called buttons, and then inside of square brackets we give it rows and we give it cols. And what this does is this creates the basis of the two-dimensional array. So we've got rows, which is 1 dimension, and then cols, which is the 2nd dimension. A single dimension array would look something like this. We could say int hello there, and then in square brackets we could say 4 equals curly bracket 1 6 5 3, something like that. And what this does, it says it tells this array that there are 4 values that it's storing, and then in the curly brackets these are the values that are being stored. The layout of this array here is still a little foreign to me. I have to go back and see exactly what they mean with the commas and the curly brackets on each of the rows. But to me it just looks like this is row 1, row 2, row 3, row 4, and then the commas are a break for each of the rows, instead of using the semicolon, which is actually terminating the entire array here. I was trying different things to see if I could figure out why it ties in the way it does, but I didn't have much luck. But let me see if I can do it like that and see if it'll compile. So it will compile. So it's basically saying row 1 is here, row 2 is here, separated by commas, and then if I put this up here, this kind of makes sense to me now. Because we're saying that there's 4 rows, 4 columns. This is row 1, this is row 2, this is row 3, this is row 4. You could fit them all onto a single line, but they lay it out this way because C doesn't really care much about spaces, and it's gentler on the human eye to see it broken down into this structure. It's kind of like, in a way, it's kind of like when you define a function, you put the parentheses and then you could put your numbers in, something like that. So I won't reinvent the wheel, I'm just going to copy that, paste it in. And then we have a byte called row pins, and this ties to rows. So this is telling the byte that row pins is a single dimension array, and it's utilizing the rows constant up here and saying that there's 4. And what these are these are the input pins on the hero board for rows and columns. So if you look on the physical board, nine, 8, 7, and 6 tap in from the row pins on the PCB, and 5, 4, 3, 2 tap into the column pins on the PCB. Underneath that, we're utilizing the keypad library by calling up keypad, and we're giving it a name of custom keypad, which is just a variable name, just like you would declare an integer. We could say integer custom keypad 1 or something like that. And it's the same basic thing, but because of the additional library, we're creating the variable under the keypad library. And then underneath that, the keypad library actually has functions inside of it, one of them being this make key map, and we're using the buttons variable up here. Inside of that, we are telling it to use the row pins and col pins pin assignments, and inside of that we're using rows and cols. Terminate that with our parenthesis and semicolon. In our setup, all we have here is serial.begin with our transfer rate. I said in a previous video that this was to work with PWM, but this isn't really the case. This is only for activating the serial monitor. PWM is just something that happens as a result of which pins you're plugged into. Any of the pins with the little tilde next to it will generate PWM when you use analog output values. Inside of our loop, we just create a character variable called custom key, and custom key ties back to the custom keypad value up here, utilizing the get key function. And then there's an if conditional that says if custom key, which is just shorthand for if custom key is true. So you don't really have to type all that. You just say if custom key, and that just means if any of the keys are pressed, or if any of this variable gets activated, it dives into this function, which links up to here, which pulls this information and it outputs through the serial.println custom key. If I compile that, see if there's any errors. Looks good so far. You can upload. Go to the serial monitor, and then when I press one of the buttons, you'll see that they do register as I press them. So I found that by changing these 2 byte arrays, I could kind of rotate the keypad buttons around, because the way that it's set up in the example, you're looking at the keypad as if the output pins are facing down, but when you put it on the table next to the hero board, it may make more sense for you to rotate the numbers around so that 1 is the upper left-hand corner of how you're looking at it, rather than having to twist the board and have it be the upper left-hand corner after you twist it. So you can manipulate your rows and your columns by just reassigning these 8 pins, and then you could test it out and see, or you can just look at the diagrams of the keypad and kind of figure out which pins link to which push buttons. So that's pretty much it for this lesson. This was a short one, but it does have a lot of new things. Again, I didn't really watch the video too in depth to see if they broke this all down. We just kind of figured it out on the fly as we're all sitting here watching. But it does make sense. I do understand what they're getting at here. I am learning a lot as I go along with this. I wish I could retain it as well as I could if I were 20 years younger, to be quite honest with you. I think my biggest issue at this point is just going to be repetition. I do have to use this more and create more of these keypad arrays and things like that. Don't get into the habit of copying and pasting, because if you copy and paste, you don't get that muscle memory from the repetition of actually doing it. So don't fall into those holes. If you get into this type of stuff, don't become complacent and copy and paste everything, because one day your copy and paste isn't going to be available and you're going to be stuck trying and remember how you key in all this stuff. So that's why I do this and replicate it in real time. That way it helps build muscle memory from doing it once, doing it twice, having to redo the video, doing it 3 times a lady. So that'll wrap up tonight's video. I hope you guys are enjoying the content. I did notice that the MCO CNC videos are getting a little bit more traction than the Arduino videos. I know that there's a lot of Arduino content out there, and I'm competing with a large market of people who are very well versed in this stuff, way more than I am. So I'm not doing this for the engagement. I'm doing this more for my own good. But I do hope you're enjoying the videos. I hope you're enjoying the diverse content that I put up. If you haven't already, please be sure to like and subscribe. I did notice that there's a lot of people that are watching videos and they're not subscribed to the channel. If I had as many viewers as I had subscribers, I would have twice as many, if not more, 3 times as many subscribers. But I do have a fair amount now, 625 last time I checked. Thank you guys for helping build the channel, and thank you for your continued support. I definitely appreciate it, and the more people that engage with my content, the more I'm inclined to make more videos and try to find new avenues and things to try out and show you guys. And I do plan on getting back onto the Linux stuff very soon. As you can tell by the recent videos, I was playing around with my machine, or one of my machines, last night and the night before, trying to get something to work, and I was successful getting it to work, so I was happy with that. And I said, you know what, I haven't made a 30-day Arduino video in 4 days, so now I'm probably on day 17 of day 11. So I digress. But again, thank you guys all for watching. Thank you for your continued support. Please be sure to like and subscribe, and we will see you soon.